Hello everybody. So today I want to talk about how you can graph a function like this without a calculator, okay? I'm sure if you had a nice graphing calculator or you found an online graphing calculator, then you could plug this in and it would graph it for you. It'd be no big deal, but and although I'm not opposed to that and I don't really have a problem with it, I would be a little uncomfortable if you were a STEM major, a science, technology, engineering, or math major, and you didn't know how that graph was put together. So I want to show you and make sure that you know how you can graph something like this all by yourself with just paper and pencil, okay? Or with just your mind if you have a good enough imagination and you don't need to write everything down. So here's my function. This kind of function is called a piecewise function because it's not just one equation, or it doesn't have just one component to it. All functions are that you plug x in and you get y back out. This particular function, where you plug the x in depends on what the x is. So, you might look at this as if it has parts. Like for example, let's do something like this. This is one independent part all by itself. If you're plugging in an x that's less than -2, then it goes in there, in that particular formula. It doesn't go in these other ones. It goes in that one. And so that's how they're all separate, okay? Anyway, so that's a piecewise function has that nature. Second comment I'll say before I graph it is that every single one of these formulas is by itself a line, and the last one, -2, is a horizontal line. So in other words, like if I said, well, this first one is y equals 2 minus x, that would be accurate for what this first component is. That is of the form y equals a number m times x plus another number b. It's -1 times x plus 2. It's a line. You can plot as many points as you want, but it's going to be a line no matter what. Same thing with this one, and then that last one's horizontal. So here's how we'll do this by ourselves, without a calculator, in other words, is we'll plot some points, because that's what a graph is. It's just a bunch of points that are correct numbers for the function. So let's take this first one. So if x is less than -2, I plug into 2 minus x, okay? So here's my x in this column, and here's my y in this other column. So I plug in x less than -2. Now I think if you want your graph nice and complete without any gaps in it, we'll start at -2, okay? And then we'll go less. So -2, -3, -4. How many points do you need to draw a straight line? One's not enough. 3's more than you need. 2 is the right number, but I went ahead and included a third one just for confirmation. So anyway, so I take -2, I plug into this formula, 2 minus -2, that turned out to be 2 plus 2 or 4. And I plug in 3, I get 5, I plug in -4, I get 6. Okay, and I put that this one should be open. Why is that? Well, this right here, does it actually say you can plug in -2? What's our rule? For x less than -2. Is -2 less than -2? It's not, okay? But it's a nice round number to start with, so we'll do that. But since it's a less than, we'll leave the point open, okay? All right, now that takes care of this top one. We'll go to this next one, x plus 3, if x is greater than or equal to -2, but less than 2, okay? So here we are. The x in this column is greater than or equal to -2, but less than 2. So again, I want my graph to be complete without gaps or anything. So I'm going to start with -2. I'll plug in there. I get 3. Or I get 1, sorry. Then I think it's nice to have something in the middle. I said you only need 2 points to draw a line, but I'll include a third one. So 0, that's in the middle. Okay, so I put 0 and 0 plus 3 is 3. And then I go over to that last barrier. It says, up to 2. So I go ahead and plug in 2 and I get 5. But again, I'm going to say this one's open. Does it say that you can put 2 in? It says x is less than 2. 2 is not actually allowed, but it gives us a nice round number to go to the end, all right? And then we get 5, but that must be open. So that takes care of this second one. Now this last one says y is negative 2 if x is more than, greater than, or equal to 2. So for x greater than or equal to 2, y is just negative 2. That's why if you ever have y equals a constant c, some fixed number c, such as y equals negative 2, you get a horizontal line. Because that means, okay, the x is greater than or equal to 2. So we'll start with 2, then maybe we go 3, 4, and so on. But you're just going to get negative 2 no matter what. You know, there's no formula to plug into. It just says y is negative 2 no matter what. All right, now I got way more points than I need right now, okay? And I'm going to plot them now, and I'm going to see what it looks like. So here they all are. There's that first point, negative 2 and 4, right? But that should be open. Notice how I drew it with an open circle. And then these other two right here, that's going to be negative 3 and 5, negative 4 and 6. Now, notice how I drew this line to continue beyond the points that are actually on my table. Why did I do that? Well, because the formula allows for x to be less than negative 2. So I could keep going. I mean, it would be ridiculous to continue doing this because at some point we know what it looks like. Sorry, got interrupted. But this will continue forever. And so I have to say, well, it is a line and it will continue off in the direction that whatever pattern has been established by the points that I found. Okay? All right. Now let's go to this middle one. I plot these points, leaving that one open. So you got negative 2 and 1, 0 and 3, and then 2 and 5, with that one being open for reasons that I talked about up here. Open points are always associated with less than or greater than, okay? Closed points are always associated with less than or equal to or greater than or equal to. Okay, so then that's the middle part. Now why don't I have some arrow going off in this direction like that? Why didn't I do that this time? Or in that other direction? Well, because this middle function, this middle portion of this piecewise function is just from negative 2 to 2, and that's it. It doesn't go left of negative 2, and it doesn't go right of 2. So that's why it does not continue beyond the points that I have, all right? Now, if I get the last one, I'll be done. So 2, negative 2, 3, negative 2, 4, negative 2. Okay, so that's 2, negative 2 right there. 3, so see how they're all like, no matter what the x is, the y is negative 2. That's why it's going to be a horizontal line, and it goes off to the right with the arrow saying I'm continue forever that way. Why is that? Well, because the formula was for x greater than 2, so I could keep going. So 5, 6, 7, negative 2, negative 2, negative 2. Greater than 2, it's going to go forever, right? Okay, so it looks like that. Now, if we saw this question on my math lab, then, you know, it might look something like this right here. Okay, there it is. And we'll have to just pick whichever one that looks like it matches what we have. And the one that looks like it matches what we have is this one. Okay, isn't that correct? Like the others, either put this middle part going the wrong way and this part here in the wrong spot. I mean, you just look at them and they don't all match up with what I found. Okay, all right, so it's going to be that one, and then we'll check it, and it's correct. Okay, now, like, obviously you could do this faster than me. You could, I mean, I use way more points than I actually need to figure this out, but I wanted to get a really complete picture for you to look at. Nonetheless, hope that helps, and you can always ask to see more examples if needed.